Hi, welcome back to CMA 8th grade math. As you can tell, I'm not Mr. Grady nor Mr. Shrug. My name is Jasmine, and today I'll be guiding you through a lesson on slope vocabulary and slope-intercept equations. So, like any lesson on this channel, we're going to be going over our plan for this lesson. We're going to use our prior knowledge of ratios and proportionality to understand slope-intercept and new vocabulary. We're going to learn about slope vocabulary and slope-intercept equations and apply our new knowledge to graphs, tables, and word problems so that when you exit this video, you're confident in your abilities. So, we're going to review vocabulary. Slope was once called our constant of proportionality. It basically describes a line's steepness and direction. It's usually written as the ratio of y over x, and its other names include rate of change, rise over run, the change in y over the change in x. Y-intercept. Y-intercept is where the line starts on the y-axis if it doesn't already start as 0, 0. It is represented as the variable b in our slope-intercept form. Proportional lines. A line is proportional if it is starting at the origin, is straight, and it goes up and to the right. If you follow these criteria, you can determine if a line is proportional or not. Linear. Linear classifies a line. It basically means that the line is straight. A line doesn't have to be proportional to be linear. It just has to be straight, of course. Slope-intercept form. Our slope-intercept form is just a basis of y equals mx plus b, where y and x are variables, m is slope, and b is y-intercept. So we're going to practice writing and solving slope-intercept form. So grab a piece of notebook paper and a pencil and follow along. I'll give you a couple of seconds to get your materials out. Okay, so Amanda has $10. She decides that she wants to save up for a new book. Every week she gets $15 as an allowance. Write the equation in slope-intercept form for Amanda's situation. So before we move on, let's identify our independent and dependent variables. Our independent variable will be our x-axis, and our dependent variable is our y-axis, but it also relies on the independent. So you can think to yourself, what can we change in this problem? If you said that we could change the weeks, then you're correct. We can change the amount of weeks that go by, but we can't change how much Amanda gets for her allowance. So weeks will be our x-axis independent variable, and money will be our y-axis dependent variable. Anyways, back to finding Amanda's equation. We know she starts out with $10, not 0, and if she starts out with $10 and dollars is our y-axis, is 10 our y-intercept? It is. It leaves us with 15. If y and x are to remain variables, and we already have b, what's left in our slope-intercept form? That would be slope, or m. 15 will be just before x, as you can see here. And for this equation, you can write 15x, or we could write 15 over 1x like an improper fraction. And then over here, you can see the plus b, or plus 10. And please note that it doesn't always have to be plus. It can be minus a value. Now on to our second question. If Amanda saves up for 5 weeks, how much money will she have by then? Well, up here we have our basic equation, but now where will we plug in 5? We already determined that x is weeks, so 5 would go in the place of x, so it would be 15. 15 times 5 plus 10. now I'm going to give you some time to solve the equation, and you can pause the video if I don't give you enough time already. Alright, so here we have our basic equation, and we're going to substitute x for 5 and put parentheses around it so we signify multiplication. And so 15 times 5, as you can see over here, is 75. And then you'll add 10 to it, which will make y equaling 85. So Amanda will have $85 by 5 weeks. Now, like in our plan earlier, we're going to have to graph it. We labeled our x and y, weeks, and amount of money. And so our independent is always x and our dependent is always y, as a reminder. So I labeled my x-axis with 1s, and then I labeled my y-axis going up by every other line, and so it'd be 5, 10, 15, and so it goes up by 10. So if you go up to 5 weeks over here, and you go up and go over, you'll see that it connects to $85. And then if you look at these points, they all connect at points where our x and y intersect properly. If you look over here on your y, you'll see that the line does not start at 0, 0 in this corner, but at 10. This is signifying the $10 that Amanda had to begin with. So, is this line linear and proportional, or is it just linear? This line is linear, but not proportional because it doesn't start at 0, 0, despite it being straight and going up and to the right. You can see that there is a constant rate of 10. So now we're going to jump to slope-intercept equations. So here we have a table. We have our x and our y column. And so before we do anything with this, we have some rules. They're just 3, but grab a note card or a half sheet to write these down on. So our first rule is to find the slope using the table and differences between each ratio. Second, you're going to pick a point from the table and plug it into the equation. And then third, you're going to rewrite our equation using the slope and newly found y-intercept. And all of it sounds pretty crazy, but as we go along, it'll start to make some sense. So I'll let you take some time to write all these down. Alright, so on to step 1. We are going to have to find differences in our table. So we're going to find the constant rate in our x column and in our y column. So to do this, you can see that I've drawn arrows. So 2 minus 1 is 1. And so then going over to our y column, 4 minus 2 is 2. And so you'll do this so on and so forth till you have differences in your x column, and you'll have differences in your y column for each pair. So now that you've had a chance to find the differences, let's go over them. So in the x column, there will be a constant difference of 1, and there will be a constant difference of 2 in our y column. So to convert this into slope, our ratio is our y value over our x value. So instead of it being 1 over 2, our slope is actually 2 over 1. So a key thing to note is that if our differences are the same throughout the entire column, then our line is linear, straight. However, if the differences are different, then that means the line isn't going to be linear or straight. So if this is 1, then this is 5, and then it goes back to 1 and 5. Or this is 1, and then these go from 2 to 3 to 2 to 5. Or both of them have different numbers, then our line isn't going to be straight, no matter what. Alright, so we have our first step down. And so now we have to plug a point into the slope-intercept equation. So I'm going to use 1 and 2, this first point, this first ordered pair, because it has 1 in it, which makes it pretty simple. So I personally try to use a point that has 1 in it. So remember that our slope is y over x, 2 over 1. So we have a y value, and we have an x value. And we also know that our slope is 2 over 1, but we don't know b. And so now this equation that I have over here is very familiar. And so what we're going to do is that we're going to do our multi-step equations and combine like terms. And so what I'm going to do is that I'm going to give you some time to work on it. So pause the video, solve this equation, and then play it once again when you're ready to move on. So to check, you should have gotten 0 for b. So 2 over 1 times 1 is just 2. And so then we have to cancel out the 2's and isolate b and get it on one side by itself. So to do this, we'll use inverse operations. So we'll subtract 2 from both sides. And then 2 minus 2 is just 0 because we canceled both of these out. So b actually just equals 0. Now we're done with our second step. Good job, guys. So now we're going to have to rewrite with slope and y-intercepts. So I'm going to give you a couple of seconds to try and come up with what it might look like and show you guys the right answer. So go ahead and do that now. This is our new equation. Y equals 2x plus 0. When we do our third step, which is rewriting, we'll leave our y and our x as variables. Then we'll plug in our slope, and then we'll plug in our y-intercept. And remember, if you have a y-intercept of 0, you actually don't need to write it out. You can just have y equals 2x, which just means that you will start at the origin. Again, you can also write 2x as 2 over 1x, which will help you graph. So now, you're done. Good job, guys. So I hope that you guys understand slope-intercept equations and slope better now in general. Please subscribe to this YouTube channel, like this video, and share the news of this channel with your classmates and friends so that we can get this channel growing even bigger than it already has. Maybe we should aim for a YouTube play button. That'd be a cool idea. Anyways, thank you for watching. I'm Jasmine. Bye.